Within the project Collaboration for Sustainable Freight Transport, financed by the Nordic Council of Ministers, we have this demonstration called Data Capture and Sharing. It focuses on the train part of intermodal transports. In intermodal transport chains, there is a great demand for having access to up-to-date and reliable data on the location of transport resources in order to be able to plan the next steps and take action in case of deviations. The aim is to show how data can be captured automatically with a prototype of a low-cost and easily installed trackside equipment. Data from this prototype, as well as from other existing equipment, will be visualized on a dashboard that can be shared among the actors involved in the transport solution.
Lack of information is today a problem that can be addressed by automatic data capture by using RFID sensors and intelligent video gates and sharing of data. In Sweden, Trafikverket has installed some 400 RFID readers across the country. The readers are designed to keep track on trail vehicle movements connected to damage detectors, as well as logistic information like European vehicle numbers and timestamps. RFID is a cost-effective method, but covers not all needed information. European partners have launched a European collaboration within the EU Rail project with support from the European Commission to develop checkpoints where intelligent video gates are in focus. The gates can capture visible information such as wagon numbers, ISO container numbers and dangerous goods signs, but also analyze which wagon the container or trailer are transported on. The tests are operational and full-scale facilities are used. Data sharing is a matter of agreements and standards to facilitate data sharing between stakeholders.
Our task was to design a system for data extraction and also to deliver a pilot system, a proof of concept to show that this is viable also in the real world. We decided to use a form factor like this on the different nodes we were installing along the tracks. Plastic box, easy to install, easy to maintain, and also holds different type of functionality. The proof of concept system consists of an installation in Gothenburg, in Kville, Lindholmen. The following demonstration will show the functionality of that system, which includes detecting the train, reading the RFID tag, and identifying dangerous goods signs. A train being detected by an earth magnetic sensor. This event is reported to the internet and logged as data. The RFID reader identifies the tag on the train and accordingly reports that back to a database in the internet. At the same time, a camera analyzes the cargo car to see if there are any dangerous goods signs on the car. After that, the train is detected a second time by this earth magnetic sensor to be able to see the direction of the train passing by. All data are then stored on the internet for use by the researchers and also Trafikverket for their analysis.
Users can access information about the trains passing this site in a website, demonstrator website that we built. What the user can see in this website is basically information about the train's timeliness, train composition that may or may not change along the route, and even some simple indicators can be included in the visualization. We get the data from sensors that KTH have put up on the site. That is then sent to KTH MQTT broker. From there we fetch the data into Deployed, which is the RISE demonstrator platform. Once we get the data in, we transform it into a common format, the Transportation Collaboration Messaging format, which is an internal format. And those messages are built into wagon and train structures that can be fed into a database. The database is the foundation for the website, which is basically a regular website with a database, a server backend and a front end running in the user's browser.
We believe that the demonstrated technology has potential to be developed into solutions with real business value for intermodal transport. Thank you for viewing.